All right, let's talk about one of the most useful tools you can have in your coding arsenal, the state design pattern. Seriously, this thing is a lifesaver for cleaning up complex logic and making your objects way, way smarter.
But before we dive into the code, think about this for a second. Ever notice how the buttons on your phone kind of seem to have a mind of their own? How they do completely different things depending on the situation?
Well, it all comes down to one simple word: state. When your phone is unlocked, you know the drill. The buttons do their normal job. But lock it, and suddenly those same physical buttons have a new purpose. They wake up the screen. Or what if the battery's dying? Now they might just show you the charging symbol. The button itself never changes, but its behavior does. All because the phone's internal state is different. That's the core idea we're going to unpack today.
Okay, so let's translate that into the world of software. We usually handle these different behaviors with some simple conditional logic, right? An if here, a switch statement there. But, as I'm sure you know, that simple logic has a nasty habit of growing into an absolute monster.
This whole idea is based on a concept from computer science called a finite state machine. And don't let the fancy name scare you. All it means is that an object can only be in one of a few specific states at any given time. Think of a document in a content management system. It can be a draft, then move to moderation, and finally get published. It can't be all three at once, and in each state, different rules apply. So how do we typically code this? Come on, you've all seen it. A giant, sprawling switch statement or a terrifying tower of if-else blocks. What you end up with is this one poor object that's responsible for knowing what to do in every single possible state. Sure, it works fine when you have two states, but add a third, a fourth, a fifth, it becomes an absolute nightmare to maintain. Every time you add a new feature, you're terrified you're going to break something in that tangled mess.
And that is precisely the problem that the state pattern was born to solve. It's an incredibly clean, elegant way to get us out of that conditional mess. So let's look at the official definition, because this is really important. It lets an object change its behavior when its internal state changes. But here's the magic part. It appears as if the object changed its class. Think about that. The object itself, the instance in memory, is the same, but its abilities, what it can and cannot do, can change so dramatically it's like it became a totally different kind of object.
So how do we pull off this trick? Well, it's actually beautiful in its simplicity, and it breaks down into 3 steps. First, you take all the logic for each individual state and you pull it out into its own separate class. So you'll have a draft state class, a moderation state class, and so on. Second, your original object, which we now call the context, its only job is to hold a reference to whichever state is the active one right now. And third, and this is the key, the context doesn't do the work anymore. It just delegates. It passes the request onto the current state object and says, you handle it. Okay, enough theory. Let's make this concrete. This will all click into place when you see it in action. Let's imagine we're building a simple audio player.
So, our player is just sitting there, waiting for something to happen. It's in the ready state. The user hits the play button. The click play method in the ready state object kicks off the music, and then, this is crucial, it tells the main player object to switch its state over to playing state. Now the player is in the playing state. The music's going. The user does the exact same thing. They click that play button again. But because we're in a different state, the result is totally different. This time, the click play method in the playing state object stops the music and transitions the player right back to the ready state. Same action, different state, completely different outcome.
And just to drive the point home, let's say we have a third state, locked state. Maybe the screen is off. The user clicks play and what happens? Absolutely nothing. This is what's so powerful. The main audio player object has no ifs or switches. It just says, hey, current state object, the user clicked play, do your thing. And the state object handles the rest. It's so clean. So now you've seen the how. Let's get down to the when and the why. When should you actually reach for this pattern in your own code? What are the telltale signs?
Well, the biggest red flag is when you have an object that behaves dramatically differently based on its current state. If you open up a class and you have to scroll for what feels like an eternity past a giant switch statement that's checking for state, ding, 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 that's your cue. It's also a fantastic choice if you anticipate adding new states in the future, because you can just add a new state class without ever touching the ones that are already working perfectly. Now, let's be real. No pattern is perfect for every situation. The pros here are huge. You're organizing your code beautifully, following principles like the single responsibility principle, since each class has just one job. You're also following the open/close principle because you can extend functionality without modifying old code. But there's a flip side. If you only have, say, 2 simple states that aren't going to change much, creating a whole bunch of classes might be using a sledgehammer to crack a nut. It can be overkill. So, use it wisely.
So I'm going to leave you with a question to think about. In the code you're working on right now, I guarantee there's a messy, tangled, conditional state machine hiding somewhere. Where is it? Go find that beast and see if the state pattern is the key to finally taming it.